All right, picking up where we left off. So we've actually come back. This is day 3, but we're going to finish the slides for day 2. And at the end of yesterday, we were looking at appending data, and we created some restricted data set using the Walmart data. We kept only observations where the opening year was 2000 or later. We saved it as a temp file, and then we restricted the full data set. After restoring it, we restricted it to all observations where the open year was prior to 2000, and then we appended the two. And this is obviously not the only way that we might want to append data. We may actually want to append any data set that we got where we, say, got it for the 1980s, another one where we got for the 1990s, another where we got for, I guess they call it the noughties, 2000 to 2010. You might append all of them together if that's how the data were presented.
A question on appending. Do we need to have like the same sets of variables? Like what would happen if we tried to append a data set with?
That's a great question. So why don't we actually take a look at an example there? So I may want to open up my my settings file and run that. And then maybe I'll open my store openings clean file. And this is everything that we were asked to do yesterday, including putting all our variable and value labels on. I'm just going to run that right now. But if we look at this, tab open year, we can see that we've got everything from 1962 through to 2006. It was January of 2006 when that ended. So let's try doing just as you asked. Let's use sort of what we did here. So let's keep if open year is greater than or equal to 2000. But then we're going to do something slightly different. Well, let's actually keep all of these, and then we'll delete a variable in the next set. So let's, what we want to do is temp file later DTA and then save it. So temp file later underscore DTA, or call it whatever you like. I'm going to save in quotation marks later underscore DTA, calling it as a local. I'm going to replace. And then I did not preserve earlier, so I am going to have to rerun this file, but that's okay. Now I'm going to keep if open year is less than 2000. So tab open year, we can see that we have everything from 1962 to 1999. And if we describe the data, we can see all the variables that we have. So let's drop everything except for, say, store num, open year, county FIPS, and store type 2. So we only have 4 variables now. What happens if we try to append a data set that has, for example, those variables, but does not have, or sorry, it has more variables as well? So append later underscore DTA. Oops, append using. And now we can see that we've got all these variables again. If we tab open year, we see that we've got through to 2006. But say let's try to list store type, which was included in our later DTA data file, but we had dropped from the previous to 2000 data. And then let's include store type 2. So remember, in the years prior to 2000, we had kept store type 2, but not store type. So now when we've appended the data, the variable store type exists in the data set, but for every year or open year prior to 2000, that variable is missing. In fact, if it was there, it would be the exact same thing as store type 2. We just created them using two different methods. But once we start seeing data 2000 and beyond, we can see that the variable is observed in the data set because it was in the 2000 to 2006 data. So does that make sense? Yeah. Hopefully we've saved everything, saved our Walmart data. Not with this done to it, but just having run our do file. And now we are going to want to import the BEA data, and we're going to want to start a new do file for this. So start that new do file, give it all of the normal stuff that you would give to a do file. Capture, log, close, log using, then your preamble, and make sure you have log close at the end of it. If you have not yet run your settings file since you opened this instance of Stata, run it.
So would it be decent, best practice, to have all of this in like a sample file that you could just like copy and get going from that?
So,
is there any reason why I wouldn't do that, I guess?
There's no good reason why you wouldn't do that. I actually I created this last night, and all I did was take my store openings data, I saved it to a new file called eitcclean.do, and then I made changes. Now you do have to be careful when you do something like that, that you're making all of the changes that need to be made. Sometimes it is better just to do something from scratch because it's pretty quick and you're not going to accidentally keep that old stuff, but yeah, I guess just be careful if you do that. So I want us to log this and call it eitcclean. We're going to log it as eitcclean or eitc_cln.text. And I called the do file eitcclean.do. So we don't have to clear that, but let's do it anyway. And then if you guys have got to the point where you've typed this out, go ahead and run it. So just that one line. And you guys should have both the .xlsx and the .csv files downloaded. I asked you to do that at the end of yesterday. If you have not, it should not be that difficult. In your do file, all you have to do is change the .xlsx version of this to .csv in these two places. That should be enough. Even here, see, I copied and pasted it, and now I see that I needed to do that. Thankfully, that didn't affect the actual running. It's just a label or a heading. And I will put that back up there if you're wondering what the code is. So, let's make sure that we've got this. So have you guys all managed to type this out? This quietly import delimited using, and then it calls the CSV file, comma var names 1 clear. Do that, and it should load the data. And it might take just a little bit to load it right here. You can see Stata's working in the background, working, and now it's done. And if that is working for you guys now, let's take a look at these data. So this is the first time probably that you've seen these data. And we can see it's a lot bigger than the Walmart data set, right? We have 57 variables, so that's a lot more than we had with the Walmart data. We also have over 70,000 observations. And you can just see the size of the data file is definitely bigger than the Walmart data. If you scroll down through this, you can also see even though the variable names were imported for this first set of variables, we still have a number that are just defined as v9, v10, v11, v12, etc. Now, if you opened the CSV file itself, so it should be in our data folder, in source, in BEA. And if you open that CSV file itself, you can see that at the top of these columns, past unit, we've just got numbers, and you can see that they're years. These are years. They go all the way to 2017. But because they are numbers, because they aren't prefaced by some non-numeric character, when it is loaded into Stata, Stata is going to say, well, those aren't acceptable variable names. You are not allowed to start any variable name in Stata with a number. You can have some letter and then a number, but you cannot start it with a number. So Stata is going to look at those and say, like, those are not valid variable names. So I'm just going to call it, well, v9 for variable 9, v10, v11, v12, etc. But it is recording those numbers that were at the top as variable labels. And we might say, great, we know what they are, that's fine, we don't need to change the variables themselves. But maybe we want to. And if we want to, this is going to be a nice, easy way to do it. Now, this is the first time, really, that you're seeing loops. And we're going to get to loops today, now, rather than tomorrow. But this is a particular type of loop. I want you to type this in like this in your do file. So it's got to be on these multiple lines, but it's got to run all at once. So I'll show you what it looks like in my do file. Looks just like this. And you're not going to quite understand it right away, but I will just briefly explain what's going on. So I'm using the for each loop. So for each v. So here I'm defining a new local. It's just for this loop. The local is v. And I'm saying for each v, so I'm not only defining v as an instance of the elements of this variable list. I say of var list. There are multiple ways of using for each. We'll see later. But here I say, okay, I want to include a variable list. So for each whatever I want to call the local of the variable list. And then I could write out all the variables. Or Stata will understand if you just say v9 through v57 in this way. And then you want to open with a squiggly bracket, an open squiggly bracket. You want to open the loop. And then at the end of it, you're going to close it. And what Stata is going to do is loop through each element of this variable list. So the first time it goes through, it's going to define v as v9. And then if you want to do other things, you'll do that. And then you get to this, and it says, great. Now I'm going to go to the next one, because I said for each. So to the next one. Then v becomes v10, and it goes through and does stuff. And then finishes and goes to the next one, all the way through v57. So rather than having to type, that many times, what would that be? 48 times. We instead just do this, and we have a much more parsimonious set of code. Then we're defining a new local. We're defining it as year. And then we do this colon. It's a special way of using this. But we say, okay, well, we want to create a variable label, and we want that variable label to be for, we're calling v here. Essentially, we want to get the variable label for this, the one that's already assumed. So for v9, we see here, if we look at v9, well, the variable label of v9 is 1969. So now the local year has been defined as the variable label of v9, which is 1969. So the local year is 1969, while the local v is v9. And then, well, we want to rename v, the actual variable. We want to rename it, and I said y, and then I called the local year, which was 1969. And once it's done that for v9, it goes and it does it for v10, and then v11 and v12 all the way through v57. So I haven't run it yet, but when I do run it, look what happens. Suddenly, all of those variables have been called y1969, y1970, etc., all through y2017. So hopefully seeing that right off the bat gives you a sense of how using loops can really save you a lot of time. And they're obviously more complex, a little bit, but if you know how to use them right, you can save yourself a lot of time. And you really want to have code not only that is more quick to write, but also is shorter for people to read, and shorter because it will take less time to run. For something like this, it's not going to be particularly resource intensive for you, but if you're working with a data set that has 20 million observations and 200 variables, and you're doing some more complex stuff, it can take a long time to run, and you want code that is going to be as efficient as possible. Well, the first thing that we probably want to do is actually take care of observations that are not really observations. So if you open the data editor and you scroll all the way to the bottom, you'll see that the bottom 3 rows actually don't contain data. They're notes. This is going to be true of a lot of data files that you try to use. Notes will be included in weird spots. Sometimes they include them on the top row, which is super annoying. If they include them at the bottom, at least you can go and do this quite easily. It might be worth you opening the CSV files or Excel files before you ever try to load them into Stata and getting rid of the notes, like just deleting them or something like that. If you think they're important notes, then maybe create a copy of the CSV file or a copy of the notes just so that you can keep them. But in our case, we do not want them. So what we're going to do, because those we can even list in 70,357 through 70,359, we can see geofips, the variable geofips contains the note, but then everything else is empty. So we actually just want to drop that. Oh. So drop in 7,357 7/70,359. And obviously you want to do that in your do file. You don't just want to do it once. You want to record it in your do file. Now, we want to do something in particular here. You might ask, okay, we've loaded these data, we've gotten rid of the non-data observations, but what are we doing here? We sort of renamed some of the variables, and great, so what? Well, I would say always you would want to actually at this point spend some time getting to know these data. And so I'm going to give you 5 minutes right now just to explore the data. You can explore it in all of the different ways that we talked about, but I want you to get a little bit of a sense of what's going on. So now that we have had a chance to explore these data, we're going to move on to actually turning it into something useful. And as was pointed out, what we want to get out of this is actually going to be EITC receipts. I guess you intuited that because my do file is called EITC clean. That was still impressive intuition. And we're going to have to deal with a few issues. First off, as some of you guys noticed, if we have the variable geofips here, and we want to work with it, we're going to actually have to turn it into something numeric. Right now it is a string. If we open up, we see it's actually quite a long string, and it's got then the FIPS code surrounded by quotation marks. If we look here at the description, it's a string of length 94. So we want to turn that into a useful county FIPS code. Now, county FIPS codes, I haven't talked to you guys about them, but in a general sense, they are assigned uniquely for each county, but within each state, there tends to be some county that has a FIPS code of 1, and then another has a FIPS code of 3, etc., and it goes on like that. And so the first 2 digits of any 5-digit, normally 5-digit zip code, the few states that have county FIPS codes with 4 digits, you can kind of think of the first digit being a 0, which makes it into 5-digit zip codes, or 5-digit, pardon me, FIPS codes. But these 5-digit FIPS codes, the first 2 numbers are actually the state FIPS codes, and then the last 3 are going to be the county-specific FIPS codes within each state. So across states, you are going to have a lot of counties that have a within-state FIPS code of, for example, 001. You are not going to have a lot that have an in-state FIPS code of, for example, 300, because there just aren't going to be that many counties in most states. Typically, FIPS codes, county FIPS codes, go up by 2, so 001, 003, 005, rather than 1, 2, 3, 4. But regardless, when we're working with them, we want to have numeric versions. We don't want to have what we see here, where we have, quote 01003 end quote after some long string of blank. You'll notice that when we have 00000, that is the United States. So this is national level observations. You might also notice that whenever we have a FIPS code that ends in 0 but has a number somewhere within it that is not 0, it is actually referring to state level observations rather than county level observations. Anytime that you get a county level observation, you are going to have the FIPS code end in a number that is not 0. So what we want to do is to turn that string geofips into a numeric variable, which we will call countyfips, CTY_fips. So we have to do a few things to this. We want to remove the non-numeric characters. Then we want to restrict our observations to include only counties. So that means get rid of the national level and state level observations. And then we want to destring the variable. So the very first thing that we're going to want to do is use this replace command, but we're going to use this substring function. And what that does, and I'll pull it up here, what that does is actually say, look, we want to take the variable geofips, we're just going to overwrite everything that exists within it with a portion of what it currently is. And with the substring command, maybe you actually want to type help substring, substr, and then you can see here we've got in parentheses s, comma, n1, comma, n2. So this function calls the substring of s, whatever variable s we put in, or some text if we want. And then it starts at n1. So wherever this, wherever the first character that we want to actually keep is found in this string, we want that to be n1, and then n2 is going to be the length. So if we want it to be 5 digits long in this case, then we are going to want to start at the correct placement, and then we are going to want to call 5 characters in the string. So they give you a few examples. If rather than calling a variable, if you actually have a string like quote A, B, C, D, E, F, end quote, then if you have 2, 3, you're going to start at the second space where B is found, and then you're going to go for 3, B, C, D, and that's what you're going to end up with. So when we do that here, we are going to replace what geofips was before with something different. So why don't we go ahead and run just that line of code, just by itself. Now if you describe geofips right now, you're going to see that it still says that it's a string 94. And if you browse, it's going to look pretty similar, except for the fact that the quotation marks are now gone. There are different ways that you could have achieved this. This is the way that I've shown you guys. Obviously I can't show you how to do absolutely every possible way of doing something, but I think that this is a very useful way of going about doing this. So now we see that we've got these FIPS codes. And they look much more like they're numeric, but in fact they are still strings. And we also have all of the national and state level observations. So the second thing that we want to do is get rid of all those national and state level observations. And like we said, any county level FIPS code is not going to end in a 0. So if any of these codes end in a 0, we know that they are not a county level FIPS code. For example, the United States level ones end in 0, and the Alabama level ones end in a 0. And you would find that for every other state. So what we want to do is actually drop every variable, or every observation, sorry, that has a situation such that the substring of geofips, which starts at the 5th place and is a length of 1, is exactly equal to the string 0. Remember, geofips is still a string variable, so you have to say it's exactly equal to the string in double quotations. You can't call it as a number, so it won't recognize it. So if we do that, remember we started with 70,356 observations. If we do this now, just over 2,000 observations are dropped. And if you look in the data editor, you can see now observation 1 is 1001. That's Otaga County, Alabama. You'll find if you go through the whole data set, you will not see any national or state level observations anymore.
What is the substring command saying there?
Using it as a conditional, as if, or just what is?
Yeah, just what is it saying? Because I understand like the one above it, the 3 through 5.
Right. So what we're saying here is that we want to drop a set of observations if in those observations the substring of geofips that begins at the 5th place, remember these are now like sort of five characters long, the one that begins at the 5th place and is a length of 1, if that is equal to the string 0, then we want to drop it, because all the all the state and national level observations will end in 0, but none of the county ones will. Again, there are other ways that you could go about doing this. Part of the reason I'm doing it this way is to show you guys substring, sub-str function, and show you how to work with these things in a tricky way. But I think this is probably how I would go about doing this.
And then I've got a question for the one above it then. So
okay.
We're starting on the 3rd character in that string, but it looked like the 1st character was a quotation mark. And we only dropped.
So yeah, I actually had to play around a little bit to see what was what. Apparently, the 2nd character was the quotation mark, and the 1st was a space.
Okay, cool. That makes sense.
Great. Any other questions? Okay, then let's type the 3rd line. Now the 3rd line is actually going to take what we have here. Remember, we've got, this is still a string, right? And it begins in 0 for anything that has a state FIPS code below 10. And then it starts going, if you scroll down enough, it starts being proper 5 digits. We want to take that and we want to turn that string into a numeric variable. And if you want to help dstring, you'll see that you do have this replace option. You could just dstring it and replace it, but we want to call it county FIPS, CTY_FIPS. We don't want it as geofips, so we're just going to generate a new variable as the option after this called county FIPS. Once we've done that, we can describe geofips and county FIPS. We see that geofips is still a string, but county FIPS is now not a string variable. If we want to, for example, list geofips, county FIPS, you get this. Let's break that. You can imagine if you didn't break that, if you just kept hitting space or more, or if you had set more off, it would have actually taken a long time to go through that. Let's actually do that right now just to emphasize how that can be kind of a pain. So if I do this, look at it go through everything. Look how long it's taking. And this is only for 70,000 observations, nearly 70,000 now. Imagine if you had 7 million. It would take quite a long time. And what are you getting out of that? Not a whole lot, if anything at all. Okay, so has everyone managed to do that successfully? What do you guys think would happen if you tried to tabulate county FIPS now? Stata is going to take issue with it. It's going to say tabulate is only going to be useful so far, and also it's going to require some resources that aren't going to be put to good use. We're not going to do that. Too many values. So if you say like, shoot, well, I know I have 68,332 observations. I kind of want to know how many counties are covered here. Do you guys remember the distinct command? If we distinct county FIPS, we can then see that out of those 68,332 observations, we have 3,106 counties covered. If we distinct line code, we find that we have 22 line code items. Then if we DI 3106 times 22, we get 68,332, which is how we get that many observations out of 3,106 counties. And once we reshape this to suit our needs, then we are going to have a situation where we have an observation for each year for each county. Now, if we reshaped this as is, with all of the line codes that we have, we would actually end up with a very large data set. And that might be what we want, but we can see that there are a lot of different line codes, and if we actually go into the data editor, we can see that the descriptions here match the line codes. So if we say tab description, oops, let's make this larger. And we can see that we have all of these different variables actually being observed. And do we want all of these? Maybe. Maybe we want some of them. In this particular case, let's say that we're only interested in EITC receipts. And you could look through a few different ways, but as you looked through, you would find out that, in fact, the line code for EITC receipts is 2320. And if you want to confirm that, you can do like tab description if line code equals 2320, earned income tax credit. And what is the earned income tax credit? I'm not really going to get into it, but in short, again, I'm not going to get into the details. In short, it is going to be a credit that is granted for work for people who make below a certain amount of money, and it sort of tops them up. And it is there's a refundable portion and a non-refundable portion, but essentially you can get money back if you did not earn enough. The government is going to be paying you extra for your time worked, and this is thought of as a way of ensuring that people who work get a certain amount of income without distorting the market by requiring a minimum wage that some people think would be above a wage that would clear the market. That assumes a lot of other things. For example, that we have an efficient labor market, that market power does not exist on the side of employers, for example, and therefore this is a good thing. The ITC is broadly thought of as having been a very good thing for welfare purposes. It's also costly. So it's benefited a lot of low-income working people, but it's quite costly. And maybe we think, oh, well, we've been looking at Walmart data, and Walmart employs a lot of people, and Walmart's wages are not particularly high. Maybe a number of Walmart workers also get earned income tax credits. And if we have Walmart data at the county level, and we have EITC receipts at the county level, maybe we could find something of interest there. And if we think that's the case, then maybe we would want to say, okay, look, at least for now, let's only keep the EITC observations. We see that that drops most of the observations in our sample. What we're left with now is 3106, which happens to be what? What are the numbers 3106? Anyone remember? It's the number of counties that we had in the data. So now we've got, for each county, we've got an observation of earned income tax receipts. And we can see this is the case. But the way that the data are shaped right now, we've got, we actually have an observation for each year from 1969 to 2017 for these counties. But each year is recorded as its own variable. And that is not going to be the most useful way for us to use these data. So we are going to want to reshape the data. And you definitely want to be careful when you're reshaping data. Stata is going to throw up a few roadblocks if you're not being quite thoughtful about it anyway, so that's a good thing. But when you're reshaping data, you want to make sure that you are reshaping it in the way that you think you are, and that is going to be how you actually want it. Now, part of the reason I say you want to make sure you're reshaping the way you think you are is because while some of the variable names are going to be different and things are going to be modified quite substantially, as I said on the very first day, you don't want to create false data. You want to make sure that you are not changing the data in a way that makes them something that they are not, or makes you think they are something that they are not. So before we get to reshaping it, let's first say maybe we don't care about every year from 1969 to 2017. Maybe we only care about 1990 to 2006. Now, the EITC underwent a number of changes, I mean, throughout its history, but in the 1990s especially. We know that our Walmart data cover from 1962 to the beginning of 2006. Because they only covered the beginning of 2006, maybe we would actually only want to keep things through 2005. But for now, let's keep things through 2006. And let's say, look, we actually know if we want to look at other variables, we may not be able to get good county-level data running back before 1990, depending on the data set. Certain data sets, like the county business patterns, you would. Some data sets you might not. So let's restrict it to 1990 to 2006. Now, we're not keeping if here. We're just actually keeping a set of variables. So we're not going to keep geofips, geoname, region, table name, line code, industry classification, description, or unit. All of the actual EITC values are recorded at this point under their year variables. So even though these variables are called like Y 1991, Y 1992, Y 1993, the actual recorded values are going to be the county level values in that year of EITC receipts. So that's all we want to keep. Y county FIPS, Y 1990 through Y 2006. And we presently have a data set with 18 variables and 3,106 observations. Now before we reshape, I want you to type help reshape. I want you to look at this for just a few minutes and see if you can make sense of what we're going to do. So rather than us just doing it, I want you to puzzle that out. So take 2 minutes and look through the help file. So what do you guys think? Are we going to do a reshape wide or a reshape long here?
Long.
Right. You do reshape long. The example that they've illustrated is a reshape wide. It goes from long form to wide form. But our data right now exist in wide form. Stub is Y, and the numbers 1, 2, etc. actually 1990, 1991, 1992, all the way through 2006. I is just county FIPS. Now, if you are actually working with maybe slightly more complex data, and you want to keep more variables than this, you would have to consider that we may have more I than this, right? We only have one I here, county FIPS, that's our unit, but maybe we'd have county FIPS and some other identifying variable. We may also have some other things that we want to consider, but we would be able to keep more variables than this. But right now what we want to do is go from wide to long. So we want to move from county FIPS, then Y 1990 through Y 2006, to having county FIPS. We're going to have a variable here. This J is going to be year, and then stub is going to be the actual values. It's going to be Y, and then we're going to rename it. It's going to be the actual values of EITC receipts in these counties. So the way that we're going to do that is type reshape long, and then whatever our stub is, in this case it's Y, it's the beginning of all of these before they're uniquely identified, is the common element in their names at the beginning. And then comma, space, I in parentheses. What are the I? In this case, just county FIPS. And space J. What is the J? It's year. Now, you don't have to say it's year. You could call it whatever you want, because we do not have any year here. This is the name that is going to give that variable when it reshapes it. I like calling year year. Maybe you don't. We've already run that. So let's run this. Now with large data sets, this can take a little while. It already did take a little while for us. With large data sets, it can take substantially longer, especially if we have multiple I. But we can see after we've run it that now, rather than 3,106 observations, we have nearly 53,000 observations. And rather than county FIPS and then each of the year variables of EITC receipts, we actually only have 3 variables. If you browse or click the data editor, you could see how it's laid out. Or you can just type list to see how it's laid out. This makes sense for county FIPS and year. For each county FIPS, we have an observation of year, right? And year goes 1990 through 2006. And then in each county FIPS by year observation, we have a value that right now is the variable is called Y, but we know this is actually the value of the earned income tax credit receipts, the total earned income tax credit receipts for that county in that year. These data are provided by the Bureau of Economic Analysis. So 52,802. Why is it that many observations? Well, we have distinct year, 17, distinct county FIPS, same as we had before, 3106. So DI 3106 times 17. This is just something you may want to do right now to convince yourself it's true. In the future, you don't need to worry about this necessarily, although it may be worth doing this sort of thing just to make sure that the data have been reshaped as you thought they've been reshaped. Again, you do want to be careful when you do this. Okay, Now let's rename that y variable. We know that y is actually total earned income tax credit receipts, so I call it EITC tote. Now we've got all three of these. And at this point I think it's worth labeling our variables, because right now we know what each of these are. Maybe year is obvious, but county FIPS, sure, it's a geo FIPS, but let's be more specific about what it is. It's county FIPS code. Year is going to be year, and earned income tax credit, total county earned income tax credit receipts. That's what that is. So let's give those variable labels here. We won't give value labels because we don't have any values of special interests that are common across observations. We don't have any categorical data here. But once we run that, we see that we've got variable labels for our variables, and we've got this nice data set. Something else you may want to do, especially after you've generated a number of variables, before you save a data set, is to compress it. So right now we see the size of the data set right here. This is not a particularly large data set, but nonetheless it's good. It is good to have your data sets storing data as efficiently as possible. You don't want to waste space, especially when you've got very large data sets. This can be an issue. So before you save something, you may want to apply compress. And compress is just going to do whatever it can to retain all of the information that is available in your data without actually changing the data themselves. You may also want to just consider, well, what types of variables are these? So we know that county FIPS is numeric, it's long. We know that year is numeric, it's an integer. But what about EITC tote? What kind of variable is that? It's a string variable. And if we want to work with that later, for example, doing this, we actually want it to be a numeric variable. So, what do you guys think would be a good way to go about changing this? Any ideas?
Probably like dstring, right? Just a command for it.
So why don't we try that?
Oh, but then you gotta generate a new one too.
Do you?
Oh, do you not?
So let's do some commands there. And what happens there when we try to do that? Has it changed it? Normally when we use this comma replace option, if a variable can be turned into a numeric value, if you can destring it, and you don't want to create a new variable, you would just use the replace option. But this is giving us this warning sign. They're non-numeric characters, so it's not going to replace it. And if you look here, desc EITC, you see it remains a string. Now maybe you want to say list EITC tote. You got a lot to look at. But maybe you want to look through and see, well, why is grief being given over this? Is there anything I can see that's coming up that looks like a non-numeric character? Have you found one?
Lots of NAs.
So give me a particular observation number for an NA so I can show it on the video.
1580.
1580, perfect. So we get to this. Oh, we've got a lot of NAs in general. We get to this, and we can see that where we've got NA, it starts for some counties at like 1990, and it goes all the way through. Why do you think that we don't have observations for those counties of earned income tax credit?
I mean, it'd be helpful to see what the counties were.
So we can see right here, for example, 2901, 2903, all these 2900s. So you guys don't know this, but Alaska, which has a number of geographically interesting things and also some interesting tax things. Alaska has a state FIPS code of 2. Often in data, Alaska, in data sets that cover the country, Alaska's data is somehow problematic. There are also a lot of changes, things that have, like regular changes. Counties that used to be some other sort of district that have then changed. So something that is often the case is that researchers decide it's useful to drop Alaska and Hawaii. You just say, we're going to keep only the contiguous U.S. because Alaska and Hawaii are kind of a little different anyway, and trying to make some or draw some conclusions based on Alaska and Hawaiian data is going to be problematic. Sometimes you may want to drop Alaska, but keep Hawaii. If you have Alaskan data, maybe you want to keep it, but it's something that is quite common. If we wanted to do that, like I said, the state FIPS code for Alaska is 2. Do you guys know the state FIPS code for Hawaii? Maybe look it up.
Is the FIPS code like a universal identifier pretty much?
So FIPS code, I think it's Federal Information Processing System.
Okay.
And yeah, these are codes that are assigned that...
So the Walmart data will have the same FIPS codes?
Yes. Yeah, so if it's a county FIPS code, then yeah, it's a unique county FIPS code, although they can change through time, and that's another one of the cautions here. If you're worried about unit changes over time, like boundaries of a county changing, or counties disappearing, being absorbed into other counties, you do want to keep that in mind and apply changes over time. In fact, you should be worried about that, and if we were going to actually work with these data, you would want to apply a fix. The most common fix might be to say, like, look, let's define counties according to some earlier value, and then just change anything that's now currently in existence back into the sorts of counties that existed before. There are other ways you might want to go about doing that. We're not going to do it because it does add an extra layer of complexity that I didn't want to force you guys to go through. But in reality, you would want to apply that change. And in general, whatever your units are, you want to make sure that they are consistent over time. if you're looking at family data, for example, you want to make sure that the families, if you assume that they are, for example, a 4-person family, you don't want to have them getting a baby at some point in there, or if you're assuming that they're staying in one place, you want to make sure that they haven't moved at some point. So whatever your units are, just be careful about that. But do you guys know what the state FIPS code for Hawaii is now?
1.5.
1.5, great. So we have 2 and 1.5. Now, do we have state FIPS code included in our data? No, but we could still quite easily drop things. So let's say we want to drop Alaska and Hawaii. How we do that? Well, like, do it this way, for example. We could drop if in list, and then what I'm going to say here is county FIPS divide by 1,000, but I'm going to say floor. So the floor function is going to round it down. Whatever it's at, whatever value it's at, it's going to round it down. The nearest integer. And then if that variable, if the variable that we are sort of not creating but would be created from applying the floor function to county FIPS divided by 1,000, if 2 or 15 are in the list of those variables, we want to drop them. So if we apply that, we can see we had 646 observations deleted. Do you think that's going to fix our data? If we apply this? Still doesn't work. We're still going to have NA. So you may want to ask yourself, how else are we going to adjust this? You say list if EITC tote equals NA. We've got to worry about some of these other things. There's not a lot of them, but there's enough. You'll see here, state FIPS 8. We don't have observations before 2002. And for state FIPS 55, we don't have any observations. So why don't you guys tell me, what are state FIPS 8 and 55?
08 is Colorado and 55 is Wisconsin.
So Wisconsin, I don't know why we don't have these data. It might be because the counties are small enough that they're worried about disclosure. You can look in the documentation for these data. I did not see in the documentation anything talking about Wisconsin or Colorado, but I might have just missed it. In general, when you're working with new data, if it's for your purposes, you should look through the documentation. I don't know why exactly Colorado doesn't have observations prior to 2001. But in either case, we have these things to worry about. And there are a few different things that we could do. We could drop all of these, or we could just recode the values EITC tote here to missings. And rather than doing 99999, I would recode it to a dot if we did that. What do you guys think we should do? What's the best approach here? Honestly, I don't know that there is a clear best approach. My inclination is for us to recode the NAs as missings. So replace EITC tote equals dot if EITC tote equals NA. Oops. This. Because it's a string. Because EITC tote is still a string, we have to include the quotation marks, double quotation marks around the dot for now. Once we've done that, does it work? So now when we hit describe, we see that all of these are numeric. You can try to compress it again, it's not going to do anything. And then we want to save it. And after that we would want to have log close. So what I want you guys to do now is run the entirety of your do file. Again, this do file should not be downloading the data, right? That should be contained within a separate do file. All you want this to do is to load the data, clean it as you've told it to be cleaned, and then save it as a .dta file. So I'm just going to run the whole thing now. And we're done.